guys, today I'm going to be solving this Leetcode medium problem called network delay time. So you're given a network of n nodes labeled from 1 to n. You're also given times, a list of travel times as directed edges, times I equals u v w, where u is the source node, v is the target node, and w is the time it takes for a signal to travel from source to target. You'll send a signal from a given node k. Return the minimum time it takes for all the n nodes to receive the signal. If it is impossible for all the n nodes to receive the signal, return -1. So this problem is involving the use of graphs. And since there are weights involved, I'm thinking of using Dijkstra's algorithm. So Dijkstra's algorithm involves the usage of priority queues or heaps. So I'm going to create a heap that's going to sort the nodes by time, and I'm going to add up all the times to find the minimum time. I'm also going to create a graph or adjacency list that's going to store the destination nodes for each source node. Alright, so I'm going to start coding. I'm going to import my heapq package. I'm also going to import my default dict package. I'm going to name it default dict as a list, hash map of list, and what else am I going to do? I'm going to create my heap, and I'm going to loop through my times. And I'm going to create my adjacency list. Now what I'm going to do is I'm going to add the source node k with the time 0 to my heap. And I'm also going to create a visited set that's going to store all the nodes that have been visited, because we want to make sure that all the n nodes are visited by the end of the sequence. Now I'm going to loop through my heap, and I also have to create a min time variable. So I'm going to pop off the first element in my min heap. So that'll be a tuple of time and node equals heapq.heap_pop heap. Next I'm going to add this node to my visited node. And if node visited, then I'm just going to continue. Otherwise, I'm just going to add a node to my visited set. And what we're going to do now, I'm going to add a time to my min time. So what else am I going to do? I'm going to loop through my adjacency list. Neighbor wait in graph node, and I'm going to add a time. So I'm going to do current time equals time plus wait. So it's going to add the wait to the previous time, and then I'm going to create a new element, push this element to my heap. So I'm going to do heapq that heap push heap current time neighbor. Now I'm going to check whether my length of visited equals n. Then if it is, return min time. If it's not, return -1. So I made a mistake. What did I make? Oh, I forgot. I'm going to be adding the time to min time. Wait, no. What? I think it's max. Yeah, that's max. Alright, so the runtime complexity of this would be of v plus e, where v is the number of nodes and e is the number of edges, and the space complexity of this would be of v, because we store in the heap. We store the nodes in the heap. Thanks, guys.